segments and circles with tangents and secants. The easiest one, or even chords, is if they're on the inside like this. If this side's 4 and that's 3 and this is 6 and 2, it's actually ratios, but it always works out. This segment times this segment will equal this segment times this segment. So 6x equals 12. X is 2. Let's say 5 and 4 and x and 10. 5 times x, or it doesn't matter which one you do first, equals, as long as it's the actual pieces next to each other, 10 times 4. 5x equals 40. X is 8. Now, yes, you can get fractions with these. You can get decimals. I just made 2 that were nice. About the trickiest they can get, let me put some letters in here. Okay, what about AE is 4, AC is 9, BE is 6. Let's find DE. So I know you're like, well, it looks the same, we just have to draw on it. Well, AE is 4, AC is 9. Well, if the whole thing is 9 and that's 4, then this piece, yep, you got it. You got to subtract 5. BE is 6. ED is what we're looking for. So that's where they tried to be tricky. They gave you part of it and then the whole, so you had to subtract to find it. Then you just get 6x. 4 times 5, 20. Divided by 6. 20 over 6. 10 over 3. 3 1/3. 3.3 repeating. Whatever your teacher or professor prefers. But usually 10 over 3 is sufficient because it is reduced. So inside, multiply the 2 on the same chord equals the segments on the other chord. Now let's say it's on the outside. We'll say x, 10, 3, 9. If it's on the outside, it's the outside segment times the whole, which is 10, equals the outside 3 times the whole, which is 12. So 10x equals 36. 36 over 10, 3.6, 18 over 5, 3 3/5. Any of those would be sufficient. So it's always outside times the whole, outside times the whole. They can even give it to you where it's, let's say, 7x 2 and 10. So outside to whole equals outside to whole. You can tell I just made this one up too. 7x equals 24. Divided by 7. 24, 7. And I know you're like, well, what about if they're sneaky? Because you know they are. They're going to have those moments where, let's say, they give you, I don't know, maybe this is 6, this, and maybe 3, 12. Well, I know you're like, wait, how am I going to find that? Because you're like, wait, it's the outside times the whole, which we don't have the whole. Now you can do one of two things. You can say x plus 6 equals outside times a whole, and solve your little mini equation by distributing. Now I know this was a terrible example. I should have used something like 4. Hindsight I would have, but subtract 36. So 6x is 0. X is 0. So let me do another one for you. That's what I get for making it up on the fly. We'll say maybe 10x 8, 20. We'll go for that one. So outside times the whole equals outside 10 times the whole, which is x plus 10. So that gives us 160. 10x plus 100. When you subtract over the 100, 60 equals 10x. There we go. X is 6. Now, if you wanted a different way to do the same thing, let me draw it again for you just to give you another frame. So we had x, 10, 8, and 20. Some of you are like, I'd really rather not do the equations. That's fine. Instead of, there's nothing that says that you have to find x first. Let's just say if I wanted the whole thing y. Because see, then you could do outside the whole, 8 times 20, equals outside to whole, 10 times y. 160 equals 10y. Y is 16. Well, if the whole thing is 16 and that's 10, 6. So notice how you still get the same, you still get the same answer. It's just whichever method you prefer. Now what about if they give you a tangent? Let's make a touch. And a secant. Let's say 8x 12. Well, notice how in this case, the outside and the whole is the same thing. So you have outside times the whole, or 12 times x, or x times 12, equals the outside 8 times the whole, which is also 8. So 12x equals 64. Divide by 12. Let's see, if we divided by 4, that would give us 16 thirds. So 5 1/3, 5.3 repeating, or we can just stick with 16 over 3. Now, rather than write it out twice, if you wanted to think of that as squaring this, same exact answer. So like if I had, let's say, x3 and 6, outside times the whole equals outside times the whole, so x squared. So when you square root both sides, square root of 27. And technically, to throw a little bit of algebra review in there, remember that actually reduces to 3 square root of 3. So that one actually had got to be one that reduced. It wasn't prime. But let's do one more. Let's say 10, 4, and let's say they want to do this again. Well, outside, but let's say for the whole we don't want to do x plus 4. Let's just give arbitrary letter y. So outside times the whole, outside times the whole, 10 times 10, or 10 squared, 100. So y is 25.